Hello and welcome to this Oracle Database World presentation about Oracle Apex Vanity URLs on Oracle Autonomous Database. My name is Todd Botker and I'm a PM Director in the Database Tools team here at Oracle. This presentation is for citizen and professional developers who build web applications on Oracle Autonomous Database. For example, the apps could be low-code Oracle Apex applications, REST endpoints on your data, or any combination of these. The technologies I will be speaking about include Oracle Autonomous Database, and in particular, the shared infrastructure version of Autonomous Database, Oracle Apex, Oracle REST Data Services, and various Oracle Cloud Network building blocks with some emphasis on the load balancer service. So if you are interested in these things, then this presentation is for you. Let's jump right in and talk about some web technologies that are included with Autonomous Database out of the box. And I'll refer to Autonomous Database just as ADB for short. These constitute the HTTP interface for Autonomous Database. And the first big piece is Oracle Apex. This is Oracle's framework for rapidly building and deploying low-code applications that look great on desktop and mobile browsers. Besides the runtime apps that you create, you also get access to a variety of helpful developer tools and administrator tools. The next big piece of the web interface for Autonomous Database is Oracle REST Data Services, or ORDS. It gives you the ability to stand up REST endpoints on your data. And if you like, you can actually have it automatically create REST endpoints on tables for you. We call that auto REST. It also includes a standard REST endpoint into which you can pass SQL and then get back JSON formatted results. We call that REST enabled SQL, or SQL over REST. And then the other big thing is the Database Actions UI. This includes a couple of things. There's a very nice SQL Developer Web IDE you can fire up and use in your browser. This is very helpful for developers in authoring, executing, debugging things like SQL statements and PL SQL scripts. It has a nice graphical data modeler. Database Actions includes a couple other helpful things too, tools for loading data, managing database users, and more. So all these web technologies are there. You get it with your Autonomous Database, and they are exposed at the default oraclecloudapps.com domain and using the default Oracle certificate. Now I want to take a moment and talk a little bit about some of the complementary OCI network technologies. Autonomous Database lives in OCI, and these things are available to extend and enhance your Autonomous Database with added capabilities. So in fact, if you remember nothing else from this presentation, remember that if there's something you're looking for from the web technology in Autonomous Database that's not there at present, it's quite possible you can build it by using these building blocks in OCI. So we're going to talk about some of these. Load balancer in particular, we'll use that for Vanity URLs, but they're very useful added capabilities that OCI provides and that you can leverage. Most of them are available for free or no extra cost. The ones that are paid services are available at very modest additional cost. Okay, so let's talk about Vanity URLs. This is a new approach to have custom domain names on these web technologies that are included with ADB. It was launched in fall of 2021, actually last month in September 2021. The default Oracle Cloud Apps domain and certificate are still very useful and widely used, especially for things like employee-facing apps where you don't necessarily need to be promoting yourself to your own employees at all times. Many of those apps are running at the default domain and using the default certificate. But we do get requests for things like SaaS apps. We get requests from ISVs who are building such apps on behalf of their clients. And these are public-facing. They're on the internet. They're facing a public audience where the ADB customer wants to promote their brand identity using their own domain and certificate, and that should be visible at all times. If it's a web app that's used in the browser, that domain name should be visible in the browser address bar at all times. If it's a REST endpoint that's exposed to developers, you want the developers to see your own domain name. So it's a very real request. And this new capability that we've just released, it leverages the Private Endpoint feature of Autonomous Database. This is an important feature for paid autonomous databases. It does require it be a paid instance. It is not present for the always free instances. But assuming you have a paid autonomous database instance, you can use this private endpoint feature in combination with some of the OCI network resources I mentioned, especially the load balancer resource, to create a vanity URL. And this approach keeps the stack autonomous. Oracle continues to take care of the regular patching, monitoring, troubleshooting, tuning, and periodic upgrades, so it keeps things autonomous. Okay, now you may be saying, wait up, back up a second. Didn't Oracle already have this capability for custom domain names? And there is this feature called Customer Managed ORDS that is available with Autonomous Database, and this has been there for some time now. It allows you to replace the out-of-the-box shared middle tier that comes with Autonomous Database with your own dedicated middle tier that you stand up, configure, and manage. And we have customers who are using this. So I wanted to compare and contrast these a little bit. Customer Managed ORDS certainly allows you to use a custom domain name, and you've been able to do that for a while, and it provides other capabilities. So how does that compare and contrast to the Vanity URLs approach? Well, with Customer Managed ORDS, it does support always free autonomous databases. Vanity URLs uses Private Endpoint, only available on paid autonomous databases, so it does not support the always free autonomous databases. Customer Managed ORDS gives you full control as the customer of the middle tier. It's a dedicated middle tier that you stand up and maintain, so you have that full control. And besides using a custom domain name, there's many more things that you can configure. It gives you the full power and flexibility that having a dedicated middle tier provides. So for example, we get some questions about controlling the database connection pool. Well, you have the ability to do that with this dedicated middle tier, this Customer Managed ORDS. So it gives you full control. Now, on the other hand, Vanity URL has some distinct benefits too. And the first one is that in Autonomous Database, there's a couple different workload types that we talk about. There's a workload type that is optimized for transaction processing and mixed workloads. There's a workload type optimized for data warehousing and analytic workloads. There's a third workload type that's optimized for JSON workloads. And then there's a fourth workload type that's really all about Apex. Now, Apex comes with all of these workload types. It's very usable there out of the box with all these workload types. But there is a fourth one that's focused, kind of specialized, very specifically on Apex. And in that workload type, we turn off some of the other capabilities of Autonomous Database not related to Apex in exchange for offering it at a much lower price point. So it has some other things disabled in order to emphasize the focus on Apex, but you get it at a much lower price. Now, that particular workload type is supported by Vanity URLs. In fact, Vanity URLs support all the workload type, Apex on any of the workload types. Customer Managed ORDS supports the first three, but not the specialized Apex service. So it does not support the specialized Apex workload type. And also, as I mentioned, Vanity URLs keep the stack autonomous. You know, we take care of the things that you expect in an autonomous offering. Whereas with Customer Managed ORDS, you do have a full customer control middle tier that you're responsible for. And there are certain things that you need to do in terms of configuring it, updating it, monitoring, tuning, troubleshooting, periodic upgrades. Those are the customer's responsibility with Customer Managed ORDS. So those are some of the key points that you need to be aware of, and they're both great solutions. They have, slightly different strengths. Pick the solution that meets your business requirements. Okay, so now we're going to get into configuring Vanity URLs using this new approach. And before I do that, I need to describe some prerequisites. So there are a couple things you need to have up front. Obviously, a domain name and a matching SSL TLS certificate. I'm not going to go into a lot of detail on how to do those things. We'll kind of assume that you know how to do that. And the ability to create DNS records for the domain. You also need to have an OCI tenancy and account, and that you need to have an account with privileges to create things like database and network resources. It does help to have some familiarity with Autonomous Database and Load Balancer and OCI network. You do not have to be an expert in any of those things, actually. A normal person can do this without being an expert, but it helps to have some familiarity with those things. And if OCI network or load balancer are things you want to brush up on. I did put a link here in the bottom of the slide where you can read a little bit more about those. Okay, so those are some prerequisites. Now, how do I set up Vanity URLs from scratch? And I'm going to do this from scratch. I'm going to assume you're starting from zero. You basically configure some OCI networking resources. You create an ADB with a private endpoint or a private IP address. And then you create and configure a load balancer, which will have a public IP address. You configure your DNS for the Vanity URL, and then you test and verify the solution. So I'm going to go into some detail on each of those steps. Starting with the first step, as soon as you sign into OCI console, you'll see at the top left of your screen a little hamburger menu. We call this the mega menu. So we're going to start by going to the networking area of OCI and selecting virtual cloud networks. And we'll create our own VCN. As you can see, I've pre-created a demo VCN here, and the act of creating a VCN it's basically specifying what address ranges or what blocks will comprise the VCN. That's the key thing that you're specifying. And you can see here, mine are going to start with 10.0. So I've specified a CIDR block for my VCN. Now I have a VCN. Inside the VCN, I need to create a couple of subnets. So I'm going to create a public subnet that will house my load balancer and will be public facing. And I'm going to create a private subnet that will house my autonomous database and will only be private IP address and inside the VCN. And I'm going to use a autonomous transaction processing database, so I've called it ATP net, and then the other one's LBR net. And when I'm defining these subnets, the key thing is you need to define the address ranges for these subnets. For the public LBR net, I'm going to use 10.0.1, and for the private autonomous database subnet, I'm going to use 10.0.2. And obviously one's public, one's private. The key thing that distinguishes a public subnet from a private subnet is in a public subnet, you are allowed to have resources within it that do have public IP addresses on the internet. Whereas in a private subnet, you are only able to configure resources that will have private IP addresses that are relevant when inside the VCN, no public IP addresses. Okay, so here I've shown you some examples, and these are some key things. Create the VCN, create the subnets. Now I'm going to start overlaying some security on this. I'm going to add what's called a network security group. This is the contemporary way to create ingress and egress rules for cloud resources. So this is what will be attached to my autonomous database, specifying what kind of traffic can go in and what kind of traffic can go out. And at the bottom, you can see the ingress rule. I'm going to allow inbound traffic from that load balancer subnet, 10.0.1, and of course I'm going to use 443 SSL TLS traffic. So I'm going to allow inbound traffic from my load balancer to my autonomous database coming from 10.0.1, and then I'm going to allow basically anything on the outbound side. You can get more narrow if you like. And then the next thing I'm going to do is set up a security list. Now, security lists have been around for a while. The network security groups are probably the more contemporary way to do this, but security lists have been around for a while and are probably more widely used just by virtue of the fact that they've been there. And I'm going to mix and match a little bit so you'll get a sense for each. The load balancer does support network security groups, but what I'm going to do is actually define a security list for that public subnet surrounding the load balancer. So you get a little smattering of each approach. And here I'm going to define ingress and egress rules for that public subnet. Again, this is public facing. We want it visible on the internet. So I'm going to allow anything coming in on 443. I'm going to allow in SSL TLS traffic in my ingress rule, and I'm going to allow pretty much anything back out. So, and you can get more narrow if you wish, but these are some basic rules to kind of get you started. So now I've got the network security group for my autonomous database and the security list for the subnet where my load balancer will be. The last thing, this is kind of the last checkbox before traffic is allowed in and out of the VCN and into the internet. The last thing is creating an internet gateway. It's fairly easy to define one. Then once I have it defined, I want to create a route table that will use that internet gateway, and I'll create a route rule that uses it. It's basically saying that outbound traffic in the VCN should be routed to the internet gateway so that it can successfully go out to the internet. So now I've got the key things that I need in place to set up my network. As you can see the boxes here, I've got a VCN, I've got my two subnets, I've got a security list and a network security group. But those boxes look a little lonely right now. So next we're going to create a load balancer in the public subnet and an autonomous database in the private subnet. Let's start with the autonomous database side. I'll go back to the mega menu, select Oracle Database, and then select Autonomous Transaction Processing. I'm going to click on Create Autonomous Database, and I'll show you the creation dialog so you get a sense for how that works. I start by selecting a compartment. Now, compartments are a nice concept in OCI that allow you to group together resources and then control access to those resources for your administrators and your developers. You can control their access to these resources through these compartments. For this demo, I'm just putting everything in same compartment, a sample compartment called Vanity URL Comp. So I'm going to put the autonomous database there too. I give the autonomous database a display name. I give the underlying Oracle database a database name. And I'm going to say I want the transaction processing workload type. And we are using the shared infrastructure version of autonomous database. Now I'm going to give the database a little more configuration. I want to use the 19C version, 1 OCPU, 1 terabyte of storage. And for the inbuilt database administrator account, I need to give that account a password. This is important as well. So this is the next thing in the create dialog. This is where I select the network access. I want to make sure to select private endpoint access. This is what prevents the new autonomous database from actually getting a public IP address. I don't want it to have a public IP address. I only want it to have a private IP address. So that's the option I select here. And then after selecting that, I am required to enter the VCN that this autonomous database will reside in and the subnet within that VCN. And I'm selecting the VCN and subnet that I created earlier. I also am required to select the network security group that will be associated to the autonomous database, providing those ingress and egress rules. And then lastly, I select the license included, licensing type, and I enter a contact email where auto-generated emails pertaining to database lifecycle and start and stop and provisioning and terminating, things like that will be sent to this contact email. So I enter an email for that. And then finally, I click on the Create Autonomous Database button. A few minutes later, and this usually lasts no more than 1 to 3 minutes, my autonomous database is provisioned and up and running. And I'll be presented with a screen that looks like this. This has all the key details about my autonomous database. And I want to make special note of its private IP address. You can see I've circled that in red because we will need that new private IP address later. Okay, so now I'm starting to flesh out the diagram. I have my autonomous database inside the private subnet. It's associated to the security group. It has a private IP, that's that solid line going up, and I'm getting a little closer. Next, let's create our load balancer. So this may be a little new to database users, and I'm going to provide some detail on how to do this. We'll start by going back to the mega menu, selecting networking again, and then selecting load balancers. At this screen, I'm going to click Create Load Balancer. We'll be creating a new one from scratch. And I'm going to be taking into a wizard that will walk me through the process of creating a load balancer. Now, the first decision I have to make is what type of load balancers. It turns out there's a couple different types that are supported in OCI. There's lower level networking load balancers that are at a lower level in the networking stack. And then there's higher level HTTP load balancers. So I'm going to select the first option, load balancer, to get an HTTP load balancer. And then I start adding details to my new load balancer. I give it a name. I select public, which means I do want it to have a public IP address. I'm going to select the shape for it as just the smallest, most basic, just for demo purposes, 1010 shape. That's 10 megabits per second, min and max. And it so happens that that is the always free shape of load balancer. So load balancer does provide a small, always free shape. And it's modest extra cost if you want to provision additional bandwidth or additional load balancer instances. But for this demo, I'm going to just go with the always free shape. Then I'm going to enter the virtual cloud network where this will live and the specific subnet where it will live. And I'm going to refer back to that LBR subnet as the public subnet that we created earlier. Now I'm taken to backends, and it's going to ask me information about what the backend is behind this load balancer. I'm going to just go with the default policy of weighted round robin, and I'm actually going to skip the add backends button for now, because after it's provisioned, that's when we're going to go back and fill in some more back-end details. So for demo purposes, I'm going to skip that for right now, and we'll do that later. I'm also going to skip the use SSL checkbox that you see at the bottom of this screenshot, because we'll go back and configure that later as well. That's SSL for the backhaul. I will enter some information for the health check. This is the ping that load balancer will send to the back end periodically to see if it's alive. And I'm going to say that I want it on port 443. I want the back end to be SSL traffic. And I want to look for status code 302, which is found. We do some redirecting behind the scenes within Autonomous Database, and we're frequently returning the status code 302. So that's the one I'm going to look for to know that my Autonomous Database is alive and up and running, and it's serving that HTTP interface. I'm also going to click on Show Advanced Options here and create an empty backend set. So I said we'll circle back to that and fill it in later, but for now I just want to create kind of a shell empty backend set. And I do that under Advanced. Now we're on to configuring the listener for my load balancer. I'll give that a name. I want to listen for HTTPS 443 traffic. And here is where I upload my certificate information. So you should have received a certificate bundle from whoever or whatever is your certificate issuer. And this is where you're uploading files from that bundle, making load balancer listener aware of the certificate information for your domain. And then lastly is a logging screen. Now in a real production instance, of course, we would want to configure logging, some very powerful web logging capabilities provided by load balancer, and then you can ship that over to the OCI logging service, which provides some nice analysis capabilities. So in a real production system, we'd want to do that, but for demo purposes, I'm going to just leave that off for now. You can always re-enable it. You can enable it later. And once I click Submit, I'm essentially done with the load balancer creation dialog. I wait a few minutes, and ultimately, I'll be taken to a screen that looks something like this. This is my running load balancer instance, and you can see a public IP address has been provisioned for it. I want to make note of that public IP address because we'll also be using that later. Okay, if I scroll down in this screen, I'll see a link for backend sets, and I can see that empty shell backend set that was created. If I drill into that, I'll see some details about it, and I click on the Edit button in the top left. And here is where I'm specifying that I want to use SSL on the backhaul, going from load balancer to my Autonomous Database. I click the Use SSL button. That makes sure that that backhaul is encrypted and using SSL. Now that connection between load balancers and Autonomous Databases, which are both Oracle Cloud services running in Oracle's cloud, that is an implicitly trusted connection. So in this particular case, it doesn't so much matter what certificate I'm using. It's not going to use their certificate. It's already implicitly trusted, and we set that up behind the scenes. So the key thing here is it doesn't so much matter what certificate you choose in this dialog, but you do want to make sure you check the Use SSL checkbox. And then inside that backend set, now I need to populate this backend set with an actual backend server. So I scroll down, I click on Backends, Add Backends, and here is where I'm going to add the information to get to my Autonomous Database. I'll add that private IP address that we saw earlier, and I'm telling it that I want to communicate only on 443 SSL TLS traffic. So now, once I've done that, I've given my load balancer the basic configuration it needs to take traffic from the outside world and route it inside the VCN to the Autonomous Database. And here you can see a more fleshed out diagram, more fleshed out picture where I've got my Autonomous Database on the bottom, my load balancer on top, and my load balancer is in the correct public subnet, protected by a security list, with my certificate. I've got my internet gateway there and my VCN there. So now we're getting closer. Okay, next we're going to configure our DNS. So whoever is your DNS provider, this could be Oracle or a third party, you go in and you want to create a record for your domain. And in this case, I'm just using a dummy kind of sample domain, example.com, and creating an A record for that domain that points to the public IP address of my load balancer. So now I've got a public IP address to my load balancer, and that may take a little while to propagate that record throughout the world, so you got to wait a few minutes at least. It kind of depends on where you are in the world and what provider you're using. But you want to wait a little while for that A record to populate, and then clients that go to your domain name, in this case example.com, that will be successfully resolved to this public IP address of my load balancer. All right, so now we've got the full picture. This is kind of the fully fleshed out picture where I've got my load balancer, my autonomous database, all my networking configured. I've wired it up to DNS. You can kind of see that at the top right. And now Apex apps or browser clients using Apex apps, developers who are using the browser to access Apex App Builder, any access of database actions UI or REST endpoints. These things will all be able to go to that custom domain, have that resolved to the public IP of my load balancer, and then be forwarded on to my autonomous database. So now I've got the full picture, and the last thing is to test and verify the setup. And this is pretty straightforward to do. Just to verify that the Vanity URL is up and is operational, I can open a browser, navigate to HTTPS, and then my domain name. I want to, of course, use SSL TLS. And the response I get back at that base path, and this base path will redirect it to /ords. We do that behind the scenes. But at this base path, I'll see the Apex workspace sign-in page. So this is the developer workspace where you can sign in. So now I know that that Vanity URL is working. And that pretty much takes us to the end of the demo, the end of the base configuration for Vanity URLs. I'm going to wrap up with this slide, which gives you some helpful links. We have blog posts published describing pretty much everything we did today. There's a link you can start with here. And we have some other helpful links here to materials that are on the web where you can read more about Autonomous Database, more about Apex, more about the dedicated Apex workload type, more about Apex running on other workload types. We also have the Apex Central site that has a wealth of helpful information all about Apex running on-premise, running in the cloud, running anywhere. All right, so with that, I'm going to wrap up. Thank you very much for your time, and I hope you enjoy the rest of Oracle Database World.